Now, how is the station resupplied? How do astronauts fly back and forth to the space station? Well, at the moment, if we look at astronaut transportation capability, there is really not much of a choice. The only option available is to use the Soyuz vehicle. This is really the workhorse of the Soviet and the Russian space program. It was first introduced in 1967, and it has been used by the Soviet Union first and by Russia later on to ferry astronauts to the early space stations, the Salyut space stations, then to Mir, and finally to the ISS. The Soyuz vehicle is launched atop the Soyuz rocket from the Baikonur Cosmodrome, and it is in many ways a truly amazing vehicle. It has an incredible history, and it has proven time and again its flexibility. Now, of course, to have just one vehicle ensuring astronaut transportation to space is not a very comfortable situation. And that's why efforts have been made in the United States to have a few more vehicles available to ferry astronauts to space. One of those vehicles is the manned version of Dragon. This is a bit of a special case. In the past, the United States has operated all its manned vehicles through its space agency, through NASA. Now, for the first time, we will be in a situation where actually NASA will be contracting transportation to the ISS from private companies. And one of those private companies is, of course, SpaceX. So hopefully at the end of 2018, we will have astronauts being launched from the Space Coast, from the Kennedy Space Center, atop a Falcon 9 rocket and on the Dragon version 2. SpaceX, of course, will not be the only company providing transportation to low Earth orbit. Boeing, with its CST-100, will start probably around the same time ferrying astronauts to the ISS. And the CST-100 and the Dragon have very similar characteristics. They both launch from the same site. They both carry up to 4 astronauts to low Earth orbit. Where they differ is really how they come back, because Dragon is supposed to land at sea, while the CST-100 will land on solid grounds. And the CST-100 will be launched, of course, atop an Atlas V rocket. Now, let's look at how cargo is brought to the ISS. And if we look at the Russian space program, we have, of course, the Progress vehicle. The Progress vehicle is a variant of the Soyuz and has been in operation in its different versions for a very long time now, from many, many years. Now, as you can see, the Soyuz is very similar to the Progress, and actually there are only a couple of characteristics, there are a couple of details one can look at to distinguish the two vehicles. One of them is, of course, windows. The Progress is a cargo vehicle, so you don't have astronauts inside, and cargo doesn't require to look out of the window. Also, the Soyuz has a periscope that astronauts can use during the docking phase, and for the Progress, this element is not necessary because there is either an automatic docking or the Progress is docked manually by the astronauts on board the station. Now, one very interesting characteristic of the Progress is the fact that it can transfer not just dry cargo, but also water and fuel. And it can transfer those fluids directly through the docking collar, which is a unique feature that none of the other cargo vehicles actually share. So The Progress launches also atop a Soyuz rocket. It launches from the Baikonur Cosmodrome, and it can carry to the ISS around 2.5 tons between dry cargo and fuel or water. Now, on the US side, we have the cargo version of Dragon. This vehicle is already in operation, is launched from the Cape Canaveral Air Force Station in Florida atop a Falcon 9 rocket, and it can carry about 3 tons to the orbit of the ISS. Now, what is interesting of the Dragon is that it can transport not just pressurized cargo, but also unpressurized cargo in what is commonly known as the trunk. But probably much more importantly, Dragon can also bring equipment back. And at the moment, it is the only vehicle that can bring back a considerable and significant amount of equipment. And this is a capability that we really want to have because, for instance, things do break down in space, and we do not necessarily understand immediately why a piece of equipment has broken down. And in that sense, it's very important that we are able to take this equipment, bring it back, study, understand what went wrong, and, for instance, improve the design of similar equipment in the future. Now, the US also has available the Cygnus vehicle. Cygnus is normally launched atop an Antares rocket off the coast of Virginia, but can also be launched atop an Atlas V. Its payload capability to low Earth orbit is very similar to Dragon, a little bit more than 3 tons, but the Cygnus cannot bring anything back to Earth. Exactly like the Progress, it burns in the atmosphere upon re-entry. Now, one very interesting vehicle that is currently under development, but which should see enter operations before 2020, is the Sierra Nevada Dream Chaser. Now, this is the only one of the cargo vehicles that takes a similar approach to the space shuttle. It is launched vertically atop a rocket, and actually the Dream Chaser has the capability of being adapted to the Atlas V, to the Falcon 9, and even to the European Ariane 5 rocket. And then it can come back gliding to a runway exactly like the space shuttle. We are very much looking forward to see this vehicle in operation probably around 2019 or 2020. Now, one final cargo vehicle to mention is the HTV or H2B transfer vehicle. This is one of the contributions of the Japanese Space Agency to the International Space Station program, and this is a very capable vehicle. It can carry up to 6 tons of payload to the ISS, and it can carry pressurized cargo as well as unpressurized cargo, and it has been used consistently to do both. It is launched atop an H2B rocket from the Tanegashima Space Center in Japan. All right, in the first part, we have covered the basics of the ISS. We have seen how big the station is, where it flies, how it communicates with the ground, and what kind of vehicles are used to ferry astronauts back and forth, and what vehicles are used to ferry cargo. Now, in the second part, we will take a tour of the most significant elements on the outside of the station, in what we can call the unpressurized part of the ISS. And of course, if we look at the station from the outside, if we look at any picture of the International Space Station, probably the most notable and most visible element are the solar panels. Now, the ISS is actually exclusively powered with the power that is collected by those solar arrays. And the way they are split is in pairs of two, and a pair of solar arrays is called a solar array wing. And on each side of what is called the integrated truss assembly, we have 4 solar array wings. And each of those elements is around 30 meters in length by 10 meters in width when they are in the fully extended configuration. Now, as you can imagine, there has never been a vehicle able to transport such a large element to space, not in its extended configuration. So actually the way it worked was to fold those solar panels and to transport them to space in the cargo bay of the space shuttle. Once the solar array wing was mounted on the outside of the ISS, it was then slowly extended till the array was in its fully deployed configuration. Now, think about that. We have a very large structure unfolding in microgravity for a length of about 30 meters. What could possibly go wrong? Well, as it turns out, quite a number of things. And in this picture here, you can see actually one of the most significant problems that were encountered during the unfolding of the solar panels. This is a picture taken in 2007 when one of the solar array wings was being unfolded. And actually what happened is that one of the guiding wires keeping the different panels straight and aligned snapped open. And because of this, a rip actually was generated inside or actually at the border between solar panels. Now, this was a very bad problem because obviously one cannot continue the extension of a solar array wing with such a rip in the panel. So at that point in time, there were really two options. Either the solar array is fixed and the extension is completed, or it has to be discarded because it simply cannot stay in space for an extended amount of time in this configuration. Now, discarding one entire solar array wing wasn't really a desirable option at that point in time, especially because in 2008, the modules of the international partners, ESA and Japan, were planned to come, and the power that was to be generated by that solar array wing was needed for, among other things, also powering those modules. So a plan had to be put together to fix this issue, and the plan was actually one of the most interesting that was ever attempted in space. One astronaut, Scott Parazinski, is the astronaut visible in the picture here, was put at the very tip of the space station robotic arm and was brought close to the solar panel so that he could actually put together the two parts with the insulated cuffs. Now, there were several problems with this plan, and one of the issues was the fact that you can't really switch off a solar cell. A solar cell is a semiconductor, and as long as the sun is shining on it, it will generate electrical power. And if it generates electrical power and there is an astronaut or any object in the vicinity, there is a risk of arcing. So the EMU, the spacesuit of Scott Parazinski, had to be properly insulated. All the tools that were used had to be properly insulated, and also the solar panels had to be oriented in a way where power generation was minimized. The EVA was also very difficult because the area that was affected was actually fairly far away. And so it turned out that the robotic arm on its own was not enough for the crew to be able to reach the affected area. So as a matter of fact, the extension boom of the space shuttle had to be mounted on top of the stationed robotic arm, and only in this configuration the crew was just able to reach that area. You see here another picture from a different EVA of an astronaut actually sorting out the different folds of the solar array wing.